Welcome to the Custom Props and Animation for Source-Powered Games DVD. This DVD is another installment of the Noesis Interactive Level Design Training Series. With this DVD, you will learn the process of importing custom 3D objects into source-powered games. You will learn to animate them, break them apart, and trigger sequences within your levels. Included on this DVD is a 30-day trial of Softimage XSI Foundation version 6. Softimage also offers a free mod tool version available from their website. Before you continue, you will need to download and install the Source SDK tools from Steam. This can be done by selecting the Tools tab and right-clicking to install the Source SDK. Then, you'll need to copy some files from the Steam user folder within the Noesis content shortcut on your desktop to your program files /steam/steamapps/your username folder on your local hard drive. You should click Yes to override the folder name and add the project files. You don't need to worry because none of your original game files will be affected. So that's it. Let's get started. Adding custom props is an excellent way to personalize the theme and atmosphere of your game levels. While there is an excellent selection of pre-made props available to you in the Source SDK, it is only by adding your own custom props that you can truly create a unique game level experience. Fortunately, you don't even need to be an experienced 3D modeler to have the pleasure of using custom props. There are literally hundreds of websites out there where you can search for custom props that you can download and then place into your games. One site in particular that I recommend is turbosquid.com. At TurboSquid, you can find a plethora of objects organized into a wide variety of styles, themes, and 3D formats. Some of the things you'll find here are free to download and use in your game level, while others are available at a reasonable price, especially considering the amount of work that goes into modeling all of these objects. Resources like TurboSquid are a modder's best friend, so remember to always give credit to the person or website where you're getting your models from. Alright, now it's time to get ourselves ready to work with the SDK. Since we'll be needing access to a few applications buried in the Explorer, let's commence by setting up some shortcuts to the programs that we'll be accessing the most frequently. Without further ado, let's launch the SDK. Once the SDK is launched, open up the Program Files folder in your Explorer. Open the Steam folder, then Steam Apps, then look for and open the folder with your username. My username in this case is Noesis3D. Within the Source SDK folder under Bin, you will find a file called Studio Model EXE. Right-click on this file and send it to your desktop. Follow suit with the file called vtex.exe. I'm going to set these two shortcuts aside for now, but rest assured we'll start using them shortly. Alright, now go up one directory into your Steam Apps/username folder. From here, you can actually simply drag and drop the icon from the address bar to the desktop and create another shortcut. Okay, let's jump back to the SDK now and make sure the current game in our Source SDK tools is set to Half-Life 2. Now that I think about it, we should actually add one more shortcut to your desktop. So get back into the bin folder within your username directory, and let's send the application called Model Viewer to your desktop. Okay, excellent. Now we're going to transition to Softimage XSI. XSI is my 3D modeling tool of choice to create my own custom props. To prepare XSI, we first need to install the export plugin. We have included the plugin on this disk, so find the Noesis Interactive directory that was installed on your computer and open Half-Life 2, Level Design Databases, Noesis Content. While we're here, it's not a bad idea to create a shortcut on your desktop if you don't already have one. Inside the Valve XSI add-on folder, you will see some options. The plugin you will use depends on which version of XSI you have installed on your computer, which in my case is version 6. Lucky for you, all the lessons and tutorials on this disk will work in any version of Softimage XSI. So let's launch XSI so that we can install the plugin. After XSI is launched, return to the Explorer, and from the folder appropriate to your version of XSI, simply drag and drop the plugin into the XSI user interface. This creates a menu that contains all the tools you'll need to import and export all the objects and props that we'll be using. The next thing we need to do is link our database. In your Explorer, go up a couple of directories into the folder called DB Level Design and go to Scenes, and then drag and drop the file name Start Scene into your XSI user interface. If XSI doesn't ask you if you want to add the project to your project list, we can add it manually from the project manager. Just click on Add Project and go to Noesis Interactive, Level Design, Databases, Level Design, and select it. Alright, now it's time for a crash course in XSI. Under the Clips menu on the top of your left-hand viewer, select the keys.psd. This brings up a useful list of some of the shortcuts that we'll be using. Let's get started with camera navigation. When I press S on the keyboard, notice how in the bottom of your XSI user interface we have the letters L, M, and R, which stand for left, middle, and right mouse button. So you can see the left mouse button gives me a tracking motion, the middle mouse button we have a dolly, and on the right mouse button, an orbit. If you take a look at the right side of the user interface, you'll see that we have select modes. Press on the big arrow to go to Object Select Mode, and then you can select the object by dragging a box on top of it. With the F key, we can frame the camera around the selected object. Now, we can actually orbit around the object. The A key will place the frame around all the objects. With an object selected, we can select its different components like points, edges, and polygons. The shortcut for points is T. After pressing T, we can click and drag the cursor to draw a box around the points we want to select. We can add to that selection by using the Shift key, or we can toggle parts of the selection by using the Control key. By pressing Control and A at the same time, we will select all the components of whichever mode we are currently in, and pressing Control Shift A, we will deselect all those components. And finally, if we press space, we go back to Object Select mode. XSI has a number of different tool sets. Right now, if you look to the left of your screen, you can see that I am in the Render toolset. By pressing 1 on the keyboard, that will change to the Model toolset, 2 for Animate, and 3 will bring us back to Render. By pressing Enter on the keyboard, we open up the Object's Property Editor. The Property Editor contains specific information about the selected object. If we select a different object, we'll get different information. By pressing 8, we get the Explorer view. This view displays all the contents of our scene. In this case, the grid, which is this object here, and the polymesh, which is the head. And we also have a default light and our camera. Pressing 9 gives us the schematic view, which is basically the same contents we were just looking at, just organized into a different layout. We have the camera, the light, and the 2 objects. Another window we'll be using is the Animation Editor. We can retrieve that by pressing 0 on the keyboard. The Animation Editor is relative to the selected object. Right now, it's the polymesh, or the grid. We'll go through these more when we start animating. Pressing Q gives you the Render Region tool. Just click and drag to begin rendering a rectangular selection of your model. Click anywhere outside the rendered region to close the window. With an object selected, you can now manipulate the object in scale, rotation, and translation. X is the shortcut for scale, C is rotation, and V is for translation. You can also click on the right side of the screen. You have scale, rotation, and translate. You can lock the tool to a specific axis, or you can click this tab for all three axes. Another option is using the manipulators in the viewer window. You can select the x-axis to scale this horizontal, the y-axis, and the z-axis, or in the middle for all three axes. The same for rotate, and the same for translate. If you select multiple objects using the Shift key, and we go to rotate, we get a uniform rotation on each of the objects. If we use COG, which means Center of Geometry, which can be found on the right side of the user interface, we can now have objects rotate around the center of geometry. You'll find this technique useful in some of the later lessons. And last is Control-D. Control-D will duplicate the selected object. Select an object, press Control-D, and let's translate that object. This will give us some separation between our duplicated objects. Press 8 to frame all, and keep moving it. Press Control-D, and then translate the object. Now that we've covered some of the basics of XSI, let's get started in moving some props into the world of Half-Life 2. We can import different types of models. We've got model, which is just an exported model from within XSI. There's also .xsi, OBJ, which is a popular object model, 3D Studio, DirectX, and there are several other add-ons available, like Lightwave importers and so on. So right now, select OBJ import, select the folder icon in the database level design directory, go to Object folder, and select Skeleton Object. By clicking on the square icon in the right-hand corner of a viewer, we can maximize the window. Go ahead and press 8 to frame all, and then from the view options, switch from wireframe to shaded. We can now see a skeleton object. Now let's assign it a texture. So reach over to the render tag, select the object, go to Material, Lambert, Texture, Image, New from File, and from your Steam apps /username /source SDK content /HL2 /material source, assign it to skull.tga. To see if it works, we can view the texture by selecting Texture Decal from our view options. By doing this, we can see that the texture is being applied to the object. This object is now ready to export as a prop, but what we're going to do is decapitate the skeleton and export only the skull. With the object selected, let's enter Polygon Select Mode and select most of the polygons that make up the skull. Now we can go to the Select submenu and choose Grow Selection, which expands our selection to include any polygons touching our current selection. By pressing the middle mouse button over the select operator, we will repeat the same command, and doing this a couple of times allows us to easily select all the polygons that make up the skull. Now we need to detach the skull from the other polygons that make up the rest of the skeleton. Pressing Alt on your keyboard and clicking the right mouse button brings up a list of options. Choose Extract Polygons, Delete. We can see what this does by pressing 8 on the keyboard to bring up the Explorer. You can see that we have now detached the skull from the rest of the skeleton. Click on the skeleton and delete. In XSI, what we're going to do is export 3 SMD files. One is a reference, one will be the physics, and one will be the skeletal animation. The reference SMD is the object model itself. The physics SMD is an object used to calculate how and where other objects will collide and react with our reference SMD. And the skeletal animation SMD essentially just defines how the reference SMD will be animated in our game. With the 3 objects exported, we then need to create a QC file. This is simply a text file, much like a table of contents, that serves as a guide for compiling the model. The QC file contains references to all 3 SMD files that we exported. We also need to make sure that we include the materials and property types. Finally, we can generate a game-ready object by dragging the QC file over studiomodel.exe. Studiomodel.exe compiles all the information in an object that we can then import into our game. In XSI, what we're going to do is export the skull object. So let's make sure our scales are set to 1s, and rotations and translations are set to 0s. And then go to the Valve source menu on the top of your screen and choose Export SMD. Here we have the options to export the model, which is the reference SMD, as well as the physics box and the skeletal animation SMD. Let's start with the model. We're going to save this into Steam/Steam Maps/your username/source SDK content/HL2/model source/textures, and here we're going to create a folder which is called skull, and in this folder we will save skullreference.smd. And now click Export. Now we have to export a physics object. For this, we're going to do the following. Select the object, and then go to the Selection submenu here, and then choose Geometry Approximation. You'll be asked if you want to make a local copy, to which you can say yes. And now go to the Polygon Mesh tab, and deselect the automatic box next to Discontinuity. This has to be done in order to export a physics object properly. Now let's go back to the Valve source menu and choose Export SMD. Select the physics box, and we'll call this file skull_physics. We will do the same for skeletal animation. We'll call the skeletal animation SMD skull_idle. And that's it. That's all we have to do right now in the 3D software. So now let's go and create a compiled object. The first step is to find the files that we just saved. They can be found under Steam Apps/username/source SDK content/Half-Life 2/model source/Noesis/skull. So here you see our exported models, our reference, our physics, and our skeletal animation. Now we have to create a QC file so we can compile it and create the model that can be imported into Half-Life 2. The QC file is a text file that we're going to create, and it contains all the properties of the object that we're going to compile. There are different types of prop objects that we can compile, and we're going to concentrate on 3. They are static props, physics props, and dynamic props. The first one we're going to take a look at is static props. If you analyze the QC file, you can see it contains a model name, which is the name we're going to give the object we create. It is going to be compiled into a folder that you want and the name you're going to give it. Next is the scale of the object. And after that, you can see we have an identifier which defines this as a static prop. Below that is the file paths to the materials we want to use. And the following line refers to the reference SMD that we just exported from our 3D application. It is broken up into two parts. One is the model entity, which is the game importable model that serves as a container for the second part, which is the reference SMD that we exported. Continuing down the list, we have the idle sequence, which refers to the skeletal animation SMD that we exported. And then we have surface property, which is in this case glass. We can change this to different properties that we'll take a look at later on. And finally, we have a reference to the physics SMD that we exported, which is a collision model for the physics engine. Now you're looking at a list of the surface properties that we can change in an object. The surface properties are essentially how an object reacts to the environment and what sound it makes when it's damaged. So, from the list you can see we have different types of concrete and rock, base rock, boulder, brick. We have different types of liquids, metals, miscellaneous. Glass is found here. Organic, like flesh, bloody flesh, foliage, snow, terrain, wood is an option. We can apply any of these surface properties to our compiled model simply by using the QC file. Next to the surface prop line in the QC file, simply type in the name of the property that you want your object to have. A second type of prop we can compile is the physics prop. This object interacts with the whole environment. This is very similar to the static prop, but the only difference is we remove the static property identifier from the QC file and we add a key values identifier. These key values tell the engine how the prop is going to react to the physical world. In this case, we're saying this is a glass and it's small. These key value parameters can be changed to different physical objects like wooden, glass, cloth, cardboard, metal, plastic, pottery, flesh, and stone of various sizes, like small, medium, and large. Another type of prop we can create is a dynamic prop, which means it can be animated. The QC file is very similar, except it doesn't have the static prop identifier or the key value parameters. The only thing we need to add is a different sequence verifying the different animation cycles we have for the object. In this case, we have an idle animation, a run animation, and a jump animation. You'll become more familiar with these QC files as we start to compile more objects. Back in the Explorer, you can see that we have the object SMDs that we exported. And if you open up the Noesis content directory and take a look at the custom props folder, you will find a sample QC file. This QC file will serve as our template for the QC file we're about to create for the skull. Click on the right mouse button in the Explorer window that contains your SMDs and select New, then Text Document. Name the file skull.qc. But before we can use this document, we need to go into the Tools menu from the Explorer window and select Folder Options. Under View, make sure to deselect Hide Extensions for known file types. You will now notice that your skull.qc file changes its name from skull.qc to skull.qc.txt. That txt won't work for us, so delete it so that all we are left with is skull.qc. Another thing we have to do is assign QC files to open with Notepad. You can do this by right-clicking on the QC file and choosing Open With. This way, when you double-click the QC file, it'll always open with Notepad so that it can be read or edited. So now we need to open up our sample QC file and the skull QC file. In the sample QC file, select all the contents, copy them, and paste them into your skull QC file. We can now close the sample QC file. Now it's time to start changing our skull QC file to what we want. So the top line will read noesis/skull/skull.mdl. The materials will read model/skull. And now we need to pick a surface property. You really can put in any surface property you want here. If you forget them, you can look at that list I showed you a moment ago and go down the list and find the one you think is the most appropriate. There's stone, for example, or rock would be a good example. So once you've decided your surface property and typed it in, you can leave the static prop identifier as is and the scale at 1. The body studio will be the name of our exported reference SMD. In our case, skull_reference.smd. The sequence idle will be skull_idle SMD, and our collision model will be skull_phys.smd. We can leave the rest of the document as is. We can see in the top line of our QC file that our model will be compiled to noesis/skull/skull.mdl. We can see where this is in our Explorer by opening up Half-Life 2 directory in the HL2 folder, Models and Noesis. The Skull folder will be created in here. So, now that we know that, we can save and close the QC file because it's time to compile. All we need to do to compile is drag and drop our QC file on top of the studio model.exe shortcut that we created on our desktop. And you can see the Skull folder has been created. Let's open up that folder and look for the MDL file. We want to be able to view MDL files in the Half-Life 2 model viewer. So right-click on the file and choose Open With. Click on Browse so that we can find the model viewer, which will be located in the Program Files, Steam, Steam Apps, Username, Source SDK, Bin, Half-Life Model Viewer. Check the box that we always open MDLs with the model viewer and hit OK. Now you will see the model viewer open, and you can see our skull there, but we don't see a texture. We still need to compile a texture for it, which we will do in just a moment. It's also important to realize that while compiling, the process can happen so fast that we may not see any errors that can occur. So what we can do to detect possible errors is create a batch file that will help us see through the process until it ends. So go to New, Text Document, and then name this text document skull.bat. Now, we need to edit the batch file. The BAT file will need the path of the program that we want to run, as well as the path of the file we want to run in that program. To get the path of studiomodel.exe, we can right-click on our shortcut in the desktop and get the properties. Under the Shortcut tab, you can copy the target path and then paste it into the BAT file. Now we need the path of the QC file, which you can copy from the top line of the Explorer bar in the Skull directory, and then paste that into the QC file. And all we need to do next is add in skull.qc at the end of the path and close it with a quotation mark. On the next line, we'll type in the word pause, and then save and close the BAT file. We now have the ability to compile our model by double-clicking this BAT file instead of dragging and dropping over studiomodel.exe. When it finishes, the window won't close, and even if there's an error, you'll at least be able to look at it. Now let's talk about textures. A material is a VTF file. To create a VTF file, we need a VMT file, which is a text file, and an image file. The VMT file is very similar to the QC file. It contains information such as how the object is lit, the path to the texture image which will be saved in the materials folder, as well as the mode in which it is lit. So let's create our own VMT file for our skull. First, we need to go into the Steam Apps /your username /Half-Life 2 /HL2 /materials/models directory, and then create a folder named Skull. Inside that folder, create a new text file. We'll call that text file skull.vmt. And like we did with the QC file, let's assign it to open with Notepad. Now, from the Noesis content directory in the custom props folder, open up the sample VMT file. Copy the contents and paste them into your Skull VMT. Once again, the top line describes how the texture will be lit in the game. Below that, we need to adjust the name of the texture to match our current model, which in our case is Skull. So now we need to compile the VTF texture. To get a VTF texture file, we need to start with an image file. The source engine limits the texture resolution to multiples of 256. Some typical resolution sizes start out with 256 by 256, 256 by 512, 512 by 512, and so on, all multiples of 256. The format of the texture has to be TGA. So once you have your texture image saved as a TGA file and in any of these specific resolutions, we just need to drag and drop that file over the vtext.exe shortcut on our desktop. So let's compile a texture. If we go into our Steam apps /username /source SDK content /hl2 /material source, you can see that we have a skull.tga. Once we compile this skull.tga file, it'll create a VTF file in our Half-Life 2 /hl2 /materials folder. So, let's drag and drop the skull.tga into the vtext.exe. Once the VTF has finished compiling, we should be able to see our skull model with a texture. So let's find our skull.mdl and open it in the model viewer. Noesis, skull, and double-click the skull.mdl. And here we have it. In the model viewer, you can orbit the skull by holding down the left mouse button and moving the mouse around, or you can zoom in and out using the right mouse button. The skull is finally ready to be imported into the game. So let's open up the SDK so that we can get into Hammer. Open Hammer, and let's open up a map called Noesisville. Noesisville is just a simple map with some custom prop objects already in place. So, the first thing we have to do is go to the entities on the right-hand side of the screen and select prop_static. A cube will appear in the map, which is the placeholder for the static prop. Hit Alt-Enter to get its properties, and go to World Model, Browse, and we can select the skull from the Noesis folder. When we hit Apply, we'll see our object that we just compiled. And you can change the angle here so that we can see our object from a different perspective. Now, let's add one more, but in this case we're going to do a prop_physics. Since our object was compiled as a static prop, we actually can't use it as a physics prop, but fortunately in Hammer, we have the option of adding a physics prop override. So now that you have your prop physics override in place, we can browse and select the same object. The benefit of using the override now in Hammer is that we can actually come here and change the mass scale and how it reacts to the world, and other things like damage it receives when a physics object hits it, and so on. So let's compile this level right now.
Uncheck this and turn off rad so it compiles faster. So once inside the game, we can see our prop static and our prop physics. Using the physics gun, you can pick up the imported prop and throw it around. You can strike down objects with it, and one thing you'll notice is that our objects are indestructible. So now, if we walk around the corner, you'll see another custom prop, the complete skeleton. And this prop will break into pieces called gibs when it receives damage. You can then even pick up the gibs and throw them around. And eventually, they will break into smaller pieces. So let's pick up this other skeleton. And let's throw him away. And bam, you see he breaks into gibs. And here's the skull. In the next lesson, we'll learn how to make these breakable objects.
Now we're going to look at how we can create gibs of an object. Gibs are essentially the parts of a larger object. So go to File, Open, and make sure you're in the Level Design database, and go to Column, and click on Column Reference. We'll create gibs using a simple object. For every object, we have to export 3 SMD files. So you can imagine, if we have 5 objects, for example, we'll have to export 15 SMD files and create QC files for each one of them. So to make things short, we're going to do things using a simple object, and then we can take it further and make it a more complex object. So right now, we have our simple object, which is a column. Included in XSI is a really neat and handy plugin that will break our objects into pieces. We can set the number of pieces we want and let the plugin do the work for us. First, I'm going to do it manually, so that depending on which version of XSI you have, you'll know how to follow the tutorial. So first thing we need to do is export the reference object. Select the object, and we actually have to make sure the texture is assigned correctly. So let's give this object a new material. Material, Lambert, then choose Texture, Image, New from File, and from the Steam/Steam Apps/username /source SDK content /HL2/material source, select column. Now we need to export our SMD models. From the Valve source menu, go to Export SMD, and let's go to Steam/Steam Apps/your username /source SDK content /HL2/model source /Noesis, and let's create a folder for the column. This will be the column reference. So just like our skull reference SMD, we'll call this column_reference.smd. And now we need to export a physics model. So we'll go to Selection, Geometry Approximation, yes, make a local copy, and then under Polygon Mesh, deselect discontinuity. And now we'll go up to the Valve source menu once again to export an SMD, and we'll change this to a physics object, and we'll call this column_phys.smd. And finally, we need to export the skeletal animation SMD. Now we have to break the object. So I conveniently added a row of points where we can do just that. So by going to Polygon Selection and then going down here and selecting the bottom part. We can extract the polygon with Keep. Press 8 on your keyboard so that we can open up the Explorer and have a look at what just happened. You can see we have the column object, which is a complete object reference, and we have the bottom part. Let's do the same thing to the top part. Go to Polygon, select the top part, hold Alt, and click the right mouse button and choose Keep. So let's rename the bottom part of the column as column bottom. And then let's rename the top part as column top. Now it's important to note that these two objects, column bottom and column top, are actually references to the larger column. If I delete the larger column, column bottom and column top will also be deleted. Column bottom and column top are our gib objects. So let's do a freeze on those. So that was one way to obtain different pieces of a single object. The other way to do this is select the object and press Alt 5 to get Softimage Net View. Go to Model, click on Create, browse down to Shatter, click on Run, 2 fragments, More Detail, and hide the parent object. What we are left with is 2 fragments. Here you can see we have one object and the second object. So now press 8 on the keyboard to bring up the Explorer. And we're going to rename these objects. Call this one top, bottom, and delete this object. So now what I'm going to do is export each object independently. So delete the top object and then go to Valve Source, Export, and this will be a model, and we'll call it columns underscore gibs underscore bottom underscore reference. We will export 2 more times. We'll do the physics model. So choose physics model from the drop down menu. We'll name this column gibs bottom underscore phys. And then the skeletal animation model, which will be named column gibs bottom idle. Now if we hit undo in our project, we can get the top part of the column back. We'll delete the bottom part so that we can now export the 3 SMDs for the top. So we'll go to Valve Source, Export, and this will be column gibs top reference. We'll export that, and then we'll do this again for the physics, which will be underscore phys. And finally, the skeletal animation with an underscore idle. Now we have to create the QC file for each one of our exported objects. Now that we have all the models exported, let's navigate to the folder where we save them. So you know the drill. That would be username, source SDK content, HL2, model source, Noesis, column. You can see that we have the reference, the physics, and the idle SMD for the bottom part of the column, as well as the top part of the column, as well as the 3 SMDs for the whole column. So the next thing we have to do is create the QC files for each one of these. On the content folder that came with this disk, you'll find a custom props directory with a column folder. Inside that, you'll find model source, and there we have some sample QC files. First, let's review the column. This is the object we're going to break. It basically follows the same principles as the sample QC file we looked at in the last chapter. The only thing that's different is that you're going to add these two collision text lines. These lines tell the engine that when the object breaks, we want the object to break into these two gibs. Gib number 1 is the Noesis column gib top, and gib number 2 is the column gib bottom. It doesn't have any health, which means these gibs won't break, and the fade time is set to 0 so that they won't fade out. If we also wanted the gibs to break up into smaller pieces, we would have to change its health property to some other number other than 0. So right now, we can just copy this QC file to our local directory, and then let's compile that. Now we need to compile the gibs, so we need 2 more QC files for that. We'll start with the top. It's the same as the other QC file. The only thing is that you need to add an autocenter command. The autocenter command automatically centers the gib model so that all the collisions and all the commands work correctly. So let's copy these 2 QC files to our local directory, and then we'll compile the first one, which is the top. And then when that's done, let's compile the bottom. It's also good to know that you can create a BAT file, which will compile all 3 QC files together. It'll compile one, and then goes right to the bottom column, and then goes to the top column. This way, if something goes wrong, the screen will pause and you can take a look for any errors. Now we have to compile our texture. Let's go back to the material source folder, find the column TGA, and let's compile that in vtex.exe. And the last thing we need is our material file, or VMT file. So let's go up to Steam Apps, your username, Half-Life 2, HL2, Materials, and there you'll see the column VTF which we just compiled. Click on the Models folder, and inside that, let's create a folder called Column. We can then go to the Noesis Content folder under Custom Props, Column, and drag and drop the pre-made VMT file which is referencing our column texture. So now, if we go to Models, Noesis, Column, we should have a few models. Column underscore gibs is the complete object. We can also see the bottom. And this one is the top. So let's bring this model into Hammer so that we can see how it works. So we've launched Hammer, and we're going to test out the column gibs. We'll start by creating a new, simple level like this. Then we'll add a character. And then we'll add a prop physics override. go to World Model, Browse, in the Noesis folder, we're going to select column gibs. So we can see the column is just a little bit too tall, so we'll make the rooftop just a little bit higher. We also need to set the health to a different number other than 0. 0 means the column won't break. We'll set it to 10 points, which is how much damage the column can take before it breaks. So what I'm doing now is raising the rooftop just a little bit so that our entire column is contained within the level. And now I want to add a weapon. We'll add the physics cannon and the RPG and the suit. The next thing I want to do is replicate the column. To do this, we hold Shift while clicking and dragging on the object. Something like this. Now, let's save this level as Noesis column test. And then let's compile it. And before I compile, I'm going to turn off RAD, which is related to the lighting of the level. And by turning it off, we will compile significantly faster. And then inside the game, the first thing we want to do is enable the developer console. So we'll get there by going under Options, Keyboard, Advanced, and select Enable Developer Console. And this way, by pressing the tilde key, which is the key right beneath the escape key on your keyboard, we can toggle the developer console on or off. So let's load up our map. It's map underscore Noesis underscore column underscore test. So currently the way these columns are configured, they're not breaking when they fall down. What I want to do is assign more physical damage to them so that when they fall down, they'll break. So I'm going to disconnect, go back into Hammer, and select all of the columns. Once all the columns have been selected, we'll go into the properties, and what we'll want to change is the physics impact damage scale. It's currently set at 0.1. If you want it to be as strong as flesh, you'll set it to 1.0. And if you look at the description below, you'll read that smaller numbers indicate stronger materials. So we want it to actually break. So what we'll do is we'll set it to 2. and then I'll recompile. Now back in Half-Life 2, I'm going to open up the map. We can see that physical damage now affects the columns. It's also interesting to notice that my character will actually collide with columns when they're whole, but sometimes the gibs themselves won't have collision detection. Let's try this one more time. Let's also give it a try from the other direction. And I missed it. One more time. So that's the basic principle of doing gibs. Notice how these two columns here are not colliding with each other? This is because there's something odd about gibs. You can actually collide with them, but it seems that they don't actually collide between each other. So that's a good reason to make your gibs smaller. Okay, so let's continue. Continuing following these same basic principles, let's go to the model source folder under Noesis, skeleton gibs, and under the folder gibs, I have created gibs for the chest, head, left arm, left leg, right arm, and right leg. And then you can also see their respective QC files. So let's take a look in the model viewer. Let's go to Noesis, skeleton, gibs, and here you'll find the gibs for the chest. Also the head, the left arm, the right arm, etc. So we can even go further and separate these pieces, and then create QC files, and then compile. So right now we have the skeleton QC file, which follows the same basic principles. We just tell the skeleton to break into the head, chest, arms, and legs. So in our next example, what we're going to do is get out the skeleton scene, pose it, export it, and then compile it with these gibs. So let's go back to XSI. Let's do a new scene. And then we'll go to File, Open, from DB Level Design, Skeleton, And let's open the rigged reference. And open the skeleton with a structure which we call a rig, which actually helps us manipulate the skeleton. Using this rig, it's very easy to pose the skeleton into any position we'd like. So let's say, for example, we want the skeleton on top of a gravestone. Let's go to File, Source, Import, SMD, and from the DB level design, let's go to the SMD folder and grab the gravestone reference. If you want, you can also open the texture, which it should be in the same folder. SMD, select, click OK. Now let's switch to the Render tab, click Texture, Image, New from File, go up to the SMD, and it should be there. There you go. So the first thing to do is select the tombstone, go to Translate, and then move it on the Y-axis until it is at ground level. Now, let's open up the Explorer by pressing 8 on the keyboard, select the Vive valve head, and let's translate that, moving it upwards. Press A to frame all, like this. Now let's rotate it and spin it a little bit, like this. And then select the upper body controller, rotate, and let's rotate that a little bit. And let's keep selecting controllers. And we're going to start posing it. Something like this. Let's select the hands. Rotate. With this here, we can control the rotation of the elbows. So move that down a little bit, like this. Just keep working your pose until you get something you like. Let's switch to wireframe. Select one of these spheres, rotate it a little bit. Move up a little bit. And let's select the inside. And select the outer box. And rotate. A little bit too much, so let's adjust it. Something like that. Now let's select the static prop, that is our gravestone, and delete it. Now that we have posed our character the way we want it, we need to export it.
So first, let's get rid of the rig. Select the object, click on Freeze, and this will get rid of the relationship between the rig and the skeleton and the object itself. Now press 8 to open the Explorer and middle click on the valve biped and delete it. Now it's time to export. With the object selected, we'll go to Valve Source, Export SMD, and under Steam, Steam Maps, your username, Source SDK Content, HL2 Model Source, Noesis, Skeleton Gibs, and then the reference. We're going to replace the one we had before, so select Model and Export. Now with the object selected, go to Selection, Geometry Approximation, and make sure Discontinuity is not selected. Now let's export the physics model. We'll go to the same folder, Physics, and lastly, the animation. So now we've re-exported the idle, physics, and reference objects. So now, let's open up the QC file. Under model name, Noesis Skeleton Gibs, let's give it a new model name, which will be posed gravestone. And here we have the skeleton Gibbs reference, then the idle file, and our physics. And we're telling the object to break into these pieces: head, chest, arms, and legs. So let's compile this. Now, from our Explorer, let's open up the Half-Life 2 folder, HL2, Models, Noesis, Skeleton, and it should be compiling to these folders. And there it is. So when that's finished compiling, we can double click and take a look at our pose. It's looking pretty good, so let's bring it inside of the game and break it apart. So let's open up the Noesisville scene and start adding some props. First, we're going to add a static prop, which is called prop static, and this will be our gravestone. Under the Properties World Model, we'll scroll through and find Gravestone 2 and apply. Let's move it up so that it's level with the ground. And now let's add a prop physics. I'm going to use a prop physics override to override some of the default parameters that we have. So let's pull up the properties and browse for world model. And this will be under Noesis, skeleton. We can go to the Noesis folder right here and then find the Noesis skeleton skeleton posed on gravestone and apply that. First thing we need to do is pose it so that it matches our 3D scene here. So we need to rotate a little bit. As well as adjust its height. So we'll move it down some. More or less like this. Now let's adjust some of the values. First thing is we want the object to break. Let's change the health to 2, and then we'll go to the mass scale, and we'll set it to a 0.5 multiplier. We want the skeleton to be sitting on top of the gravestone until it receives damage. So let's go to the health level to override motion, and let's set that to 1. And then physics impact force to override motion, we'll also set to 1. And then let's go to the flags tab and enable the skeleton to always be picked up by the physics gun. So let's give this level a try. Compile. OK. And we'll change the map to Noesisville. You can see our skeleton on top of the gravestone. So now, if we shoot at the posed skeleton, it'll break up into gibs. If I continue shooting these gibs, they too will eventually break up into pieces. So now let's restart the level. This time we'll add a couple more. Let's add a second one by duplicating this one. We'll just have them hanging from this object here. Something like that. And let's add one more. We'll put it over the stone. We can duplicate by clicking while holding Shift and then dragging. And then we'll move it over this stone right here. Let's spin it around. And lay it down here. So now let's recompile and test it. Load up Noesisville. So let's select a gun. See, we have breakable gibs. Let's try out our physics gun. These other gibs here. And let's toss them. And now let's disconnect. So let's review a little bit what we just did. We posed our character, and we exported the 3 SMD files that we needed. And then to the QC file, we added the collision text lines into the code, which will give us the gibs that we want our object to break into. And then we recompiled our models. It's important to understand that since we already had our gibs compiled, that no matter what model we used here, if we added these collision lines of code, even to a sphere, for example, they would break up into these skeleton pieces. So let's continue exploring on how we can add more custom gibs. Let's go to File, Open, and from the DB Level Design database, let's choose Skeleton, and then the skeleton posed chain. So basically, using the rig, you can pose the character any way you want. In this case, I've added some simple geometry to simulate a chain. So let's export this character. We'll go to Valve Source, Export SMD, and let's make sure we're in Model Source. Noesis, skeleton posed, we'll select the skeleton pose reference and export it as a model. And then we'll go to Selection, Geometry Approximation, and turn off Discontinuity, and then we'll export the physics model. And lastly, the idle model. So in our Explorer, let's go up one folder to the posed folder, and we'll see the skeleton posed chain QC file, which is our standard QC file. If we compile this object right now, it would be compiled as a simple object. Let's try it just to make sure it's working. So let's go to the Steam Maps, Half-Life 2, HL2, Models, Noesis, Skeleton, and let's choose Skeleton Chained, and open it in the model viewer. Here you can see the model that we just compiled. Now let's create another one with gibs. This time, I'm going to open up the QC file, and I'm going to rename it to gibs, just so that we know the difference. And then let's go up one folder to skeleton gibs, and let's copy the collision text values. And once we have those copied, we'll return to our other QC file, and add it after the collision model. Let's save this QC file as posed chain underscore gibs, so that way we know this is the character that has gibs. So let's drag and drop this QC file to the studio model.exe. So this should have compiled to the skeleton chained gibs.mdl. When we look at it in the model viewer, it will look the exact same, because it's only when we break the object that we can see the gibs. So let's try this out inside of the game. Let's open up Hammer, and let's open up the Noesisville scene, if you don't already have it open. And from our Viz Groups panel, click on User, and let's activate the hang structure and the spotlights. So I'm going to reuse one of the physics override objects that we already placed. I'm going to get its properties, and under World Model, we're going to browse, and in the Noesis folder, we should find the skeleton chain gibs. This is what we want right here. So let's hit apply. And now let's bring that model up. And let's turn it around. We can do that in the properties using the angle. So right now, since it's a physics object, if we started the game, it would fall down and collapse. So what we need to do is add some kind of constraint. In this case, we'll add a ball socket. We'll go to Objects and do Physics underscore ball socket. For it to work properly, we need to assign it to our skeleton. But first we need to give our skeleton a name. So let's go to the skeleton's properties, and we'll call it Skel1. And then we'll go to the ball socket, entity, and we'll select Skel1. This will keep the skeleton from falling. So let's give this a try. So let's go take a look at our skeleton. You can see him hanging over here. We can collide with him. You'll see him start swinging. We can pull it, throw it. But right now, he won't break. So let's return to Hammer and make this guy a breakable object. So back in Hammer, the first thing we need to do is select the object, and under its properties, set it up to receive damage. So we'll go to Health and set that to 40. And we're also going to pull it up just a little bit so that it's more in line with the hanging structure. And just for fun, let's duplicate this guy across the structure. Click on it, hold Shift and drag. And now we need to make sure to rename those objects from skeleton 1 to skeleton 2, and this one's skeleton 3. And now we need to adjust the ball socket for each one to target the appropriate skeleton. So this will be skeleton 3, and this guy will be skeleton 2. And let's make sure the 3 of them are breakable. This should be 40, which it is. So let's compile this map one more time. You can see when we shoot at these guys, they now break up into their gibs. There they go. So working with gibs is pretty fun, and it's a great way to add a dynamic feel to your maps. Now let's continue and work on animating custom props.
In the following section, we'll learn the basics of animation. We'll cover how to create a rig to animate our custom props, and then we'll learn how to create a set of animations that we can reuse and configure inside of our game. Let's start with the basics of 3D animation. Let's open up a scene from your DB level design folder and then go to animation and choose the animation start scene. On the left side of your screen, you'll see the image clip viewer. Underneath clips, select the animation keys.psd. On the bottom of the XSI user interface, you'll see we have a timeline. This timeline represents the number of frames in our animation. Right now, our timeline has 100 frames. You can see what frame we are currently on whenever you scrub the timeline. If we're on frame 65, you'll see down here it says 65. Say, for example, you want to do a 200 frame animation. You simply just need to adjust the end frame of our timeline. Underneath the timeline, we have the work area. So if you're working in a 200 frame animation, for example, and you want to view just the few frames you're working on, you have the ability to narrow your work area. Okay. Let's go ahead and turn everything back to default. So basically, we can do the simple transformations to an object. Select the object, and then we can either scale, rotate, or translate the object. Here's scale, rotation, and translation. Since we're in a 3D space, we can always rotate on any of the 3 axes, X, Y, or Z. To create an animation, we're going to set keyframes on different parts of the timeline. So select an object, and then we can use K on our keyboard to set a keyframe. Go to Rotate, and either press K on the keyboard or click on the key icon next to the timeline. You can see that it turns red. This means that in frame number 1, there is a keyframe set. If you take a look at another part of the timeline, you'll see the key icon turns green. This means the object is animated, but we're not at a specific keyframe. If you go back to frame number 1, you'll see it turns red again. So now let's move the current frame to frame number 30. Go ahead and rotate the object. And now take a look at the keyframe icon. You'll see the key has turned to yellow. This informs us that we've made a change, but we actually haven't set a key to this frame. Go ahead and click on the key or press K on your keyboard, and you'll notice that the red keyframe will appear in your timeline. Now let's jump to a later frame, do another rotation and set a keyframe to it, and one more time a little bit later, we'll do a third rotation and set another keyframe. Now, let's play our animation. To play the animation, we can use the Play Forward button in the console. Additionally, you can scrub through the timeline to see your animation. By pressing 0, we'll get our animation editor. The animation editor contains curves that represent the place and function for every transformation. In this case, the rotation on X, Y, and Z. If we click on the editor and select Dope Sheet, this will give us a representation of the same keyframes that we have seen on the timeline. You can see the purple frames mean that there are keyframes underneath, and each color represents either X, Y, or Z of the coordinate system. So what if we want to make our animation faster? Well, we can do the following. By pressing Q, we can drag a selection box in the dope sheet including all of the keyframes. Then, with the middle mouse button, we have the option of moving the keyframes together forward or backwards. And you can see in the bottom timeline your changes being reflected. So now let's move the keyframes to start at frame number 1. But instead of it having to be 80 frames, we want it to be 60 frames. We just middle click on the edge to set the keyframes. And then notice how the animation refreshes at the bottom. And now our animation goes from frame 1 to frame 60. Now when we play back the animation, it'll play back in 60 frames. So now let's say we want to make a looped animation. That would mean our last frame and our first frame need to be the same. So press Q and select a keyframe, and then we can copy that keyframe using Control-C, and then we can go to, let's say, frame number 70, just drag it on the timeline, or type it down, 70. And once you've arrived at your final frame, simply paste in the keyframe that you just copied. So now when you play back the animation, it'll play through and then end up the same as our first keyframe. If we click on the loop, you can see that we have a looped animation. So we can also play around with adjusting keyframes. With Q, select this key and move it a little bit to the left, play it back, and that's a little bit better. Now, depending on which version of Softimage you have, you might be able to modify keys in the timeline without getting into the dope sheet. This works in similar ways as the dope sheet, but just over the timeline instead. Select Shift and drag a selection area, and then use the middle mouse button to drag the keys. Once again, that's middle mouse button, and drag the keys. If you need to delete a keyframe, you can do the following. On your timeline, adjust it so that you're on the keyframe that you want to delete, and then simply click the key icon. That will remove the keyframe. Now let's say you want to copy a keyframe. To do that, let's actually first unselect the loop here. And then let's say we want to copy the keyframe from frame number 1 to frame number 80. Come to frame number 1, and then shift drag on that frame to make a region. Right click, copy, and then go all the way to frame 80, and then right click and paste. That's one good way to copy a keyframe from one place to another. So now I'm going to undo that and show you another way to copy keyframes. First, go to the keyframe that you want to copy, and then in your timeline with your middle mouse button, click and drag. You will see a green timeline indicator. Drag this indicator to the frame that you want to copy to. In our case, that's frame number 80. And when you release the middle mouse button, you'll see our object hasn't refreshed yet, but if you make sure you're in rotation and then set a keyframe, you will see that when we play it back, we will have the same keyframe that we just copied from frame number 1. To remove all the animation keyframes in a timeline, we can go to Animation, remove Animation, and then select what you want to remove, either Scale, Rotation, Transformation, or select all transforms. When you're doing a lot of animation, you'll see that the Auto key becomes a very useful tool. With Auto key turned on, make sure you select a keyframe on the first frame you're in, and then simply move on the timeline to another frame. Any transforms to your object will automatically be reflected as a keyframe. So now I'm going to make some adjustments over a few different frames, like this. And then we'll do the same thing I just showed you, which would be going to the first frame, middle clicking and dragging to frame 90, and then press K so that frame 90 matches frame 1. If you want to move in between keyframes, either forward or backwards, you can use the left or right arrow that's situated in between the Auto button and the keyframe icon. Alternatively, you can use the Control left or Control right arrow on your keyboard. While we've been working exclusively with rotation, we can animate in multiple transformations. Select Translate, and then go to frame number 1 and set a keyframe. And then on frame 35, we'll move it up a little bit. And then 68 or so, we'll move it down. And then on frame 100, we'll have it return to the same position it was in frame 1. Let's see how this looks in the animation editor. By pressing 0, you'll see we have X, Y, and Z for position and for rotation. Now let's say you want to remove the animation for that up and down motion we just implemented. Go to Animation, remove Animation, and then remove it from Translation. Now if you turn off the auto key function and take the y-axis down to 0, the object will return to its original place. To get a better understanding of how the axes work when you're animating, let's switch to a top view. Let's zoom out with Z and select the object. These reference axes in the lower left can help you understand which way to animate. So if you want the skeleton to move right, you'll use the x-axis, or Z if you want to move back and forth, or Y for up and down. So let's go to the transform, and you can see that the X is red, and your mouse cursor tells you which axis you're about to transform, which matches this axis. So if you set a keyframe on frame number 1, and then on frame number 30, you can then move the skull to the right and set a key on that frame, and you will see it move along that axis. Let's see how this curve looks in the animation editor. Press 0 to pull up the animation editor, and then take a look, and you can see the Y and Z axes are not animated. Only the X axis is animated. We can see the function curve here. And on frame 1, it has a value of 0, and on frame 30, it has a value of 49.01. If you want to change that value to 50, for example, go ahead and click inside and just type in 50. So with the S and middle mouse button, I'm going to zoom back and reposition the camera so that we can see from frame 30. If you accidentally zoom out too far, you can press F to frame your curve again. So now if we look at the curve, we can see that it has an ease out and an ease in. Slowing the motion at the beginning and accelerating at the middle, you can see it slows back down again at the end. You can also adjust these slopes. By making it something like this, the animation will accelerate and then slowly stop until frame 30. Now let's have a look if we do it the other way around. This will actually make the object go backwards and then quickly reach its position at the end. Here you can see why. It goes backwards because in frame number 1, the X value is 0. But if you go to frame number 15, the X value is negative. This is because of our slope. Our current slope will make the object go backwards. We can further tweak the keyframes by using the region tool, either by pressing Q on the keyboard or clicking on the region tool icon. Just drag a box around the keyframes, and as soon as it finds more than one, the region box will appear. Now you can select the box and drag it inwards to compress the animation, or you can expand it to make it slower. I'm going to press Z to zoom out, and Q for the region box, and make it slower. So now I have it set up so that the animation will stop around frame 44. We can also, if we want, make it move more to the right. And we can also have it start a little bit more to the left. Now, if you select the curve, what we're viewing is what's called spline interpolation, where we can modify the slopes by selecting them and then making changes. If we add a keyframe in the middle, you can see that it goes up almost to its final position, goes back again, and then goes outward to the right. So if you want to modify the slope, for example, you want to make this more linear, then select the keyframe, and then you can break the slope. Select the slopes to make them more even. And then to return to the slope, just select the unified slope. Now to delete the keyframe, simply click on the delete keyframe icon. Then click on the key to delete it. If you select the complete function curve and press F on your keyboard to frame it, you have the option of converting the curve through linear interpolation. What this does is it converts the curve into a straight line, which will give you a constant movement. Now let's say we want the object to move upwards in the middle of this horizontal motion. We need to now add keyframes to the y-axis. So let's go to the ending frame, set a key, and then let's say from frame 20 we want it to move upwards. So we'll move the skull up and set the key. Notice how my curve for the Y position has now changed. We can frame in and zoom and examine the slope. We can delete this keyframe to give us a smoother slope. We'll play that through. If you want to return to examine the X movement, you can select the X motion curve here and then frame it with F on your keyboard. Sometimes it's good to get rid of the keyframes that we're not using. In this case, right here for example, this gives us cleaner F curves and it makes it easier to understand our animation. So now let's remove all the animation from our transforms. Remove animation from transforms, and now let's reset all our transforms. Press R on your keyboard to reset the camera. We can change this from the top view to the right view. And let's start the next lesson. Let's open the scene called Rig Start. And then select from Clips, Rig Basics. So in order to pose or animate an object, we have to create what is called a rig. The whole system of bones for an object is called a rig. We can see the bones for the arms, the neck, the head, the pelvis area, the thighs, and this entire system together is called a rig. So we have an object mesh,
and then we apply the rig, and then we can either pose it or animate it. So let's learn about the basics of applying a skeleton to an object. First, we will apply a bone to the skull. So let's switch to our animation toolset. And then go to Skeleton, Draw 2D Chain. With the left mouse button, we will draw a bone. We can keep on adding bones, as many as we want, with every click. The right mouse button will terminate the chain and exit the tool. Now let's delete these bones because we really only want one. Let's go to Skeleton and 2D Chain, and let's just draw one large bone. We'll put it along the same axis where more or less the neck would be. We'll end the chain by pressing the middle mouse button so that we don't exit the tool. And now we'll draw a second bone from more or less where the jaw joint will be to the end of the mouth. Press the right mouse button to terminate the chain and exit the tool. Now let's switch to the schematic view. And on the bottom window, let's select the Explorer view. In the schematic view, you can use the Z button to move around or zoom in, and you can press A to frame all the objects. So this is our scene, and this is our skull object. You also see our two single bone chains with the root, the bone, and the effector. You can see in the Explorer this same hierarchy. For instance, here are the roots, which are the parents, and then underneath the root, you'll see the bone, which is the child, and the effector. So what we want to have happen in this scene is when we select this bone object and rotate it, the jawbone would follow it. So what we need to do is make the jawbone a child of the head bone. So let's rename that just so we know. This will be head bone, and this will be jawbone.
Now, let's middle-click on the root of the jawbone to select the entire hierarchy.
And then from the UI on the right side of the screen, select Parent. Now you can see the options at the bottom of the screen to either left-click to pick a child, middle-click to pick a parent, or right mouse button to terminate. So let's select the parent, which is the head bone. So we'll middle-click on the head bone. And then we'll right-click to end the tool. Now, under View, we can go to Rearrange All, or press Ctrl-R, which will rearrange our view hierarchically. In this hierarchy, we can see the root for our head bone, the head bone itself, and the head bone's children, which include the jawbone root, the jawbone, and the jawbone's effector. Now, when I select the head bone and rotate it, the jawbone rotates with it. One thing to note is that when you're compiling for the source engine, you can have as many bones as you want, but all the bones you have to be children of a master bone. So now let's apply this rig to the skull. First we need to select the skull object, and then under the Animate toolset, we'll go to Deform, Envelope, Set Envelope, and then it will ask you if you want to add it as an animation operator, to which you'll say yes, and then simply left-click on each bone by itself, or you can middle-click on the whole root, either in the schematic view, or the crosshair in the object viewer, or you can do it in the Explorer. Middle click, and right click to exit. A default window will come up, and usually the assigned values will be fine, so we can close that. The first thing you'll notice is that colors have been assigned to the different parts of our hierarchy. The head bone here is in yellow. The jaw bone you can see is in orange. And when we select the object, you can see the points that construct that object are tagged with the same colors that we can see in our hierarchy. Most of the head here is yellow, and the jaw part is orange. Right now, if I select the jawbone and rotate it, you'll see the result is a rubbery type, funny looking skull. For the purpose of this lesson, this is not the desired result. So we'll fix this in a moment. But right now you'll see the skull is being deformed by its skeleton, otherwise known as its rig. If we rotate the head bone, you see it's working just fine. The jawbone is a child of the head bone. But as soon as we start rotating the child, you can see we start getting a very strange deformation. So let's try to fix this. Let's select the object, go to point, and now select all the points. Let's go to envelope, and we'll select reassign locally, because what we want to do is reassign all the points to the head bone. So let's select the head bone in the schematic or the Explorer, and then click the right mouse button. Now, when I select the head bone and rotate, the same thing will happen. The entire skull will rotate. But what will happen if I select the jawbone? Let's try it out. Let's select the jawbone and rotate, and we see none of the points actually rotate. That is because all the points are now assigned to the head bone. So now, let's assign all the points of the jaw to the jawbone. We'll select the object and go to point, and select all the points we can in the jaw. And don't worry if you can't select everything, because we can go to the Select menu and choose Gross Selection. And we can middle click to repeat the operator. And this way we can be sure we have all the points selected. So now, with these points selected, let's go back to envelope and do reassign locally, and let's click on the jawbone, either in the schematic, the Explorer, or the object view. And then we'll right click. Now, when I select the head bone, everything still follows, just like we'd expect. And when I select the jawbone and rotate, we get the deformation that we're looking for. Now we can start animating. Let's turn on auto key, and then let's set a keyframe at frame 1. And then let's advance and rotate the head. Let's advance a little farther, give it a nice subtle movement, and let's change our coordinate system to local. And then we'll advance a few frames, and we want them to open wide at this point, and then we'll want them to close right here, and then we'll have them go back. So we'll copy our first frame keyframe to this frame here. So now, at this point, let's select the jawbone, and before we want him to open his mouth, let's set a keyframe, and then we'll have him open his mouth here, and then we want him to close it back over here. we can also play around with the lateral jaw motion so that we get it to look just right. Opens his mouth and closes it. We can play with these keyframes a little bit too. We'll move these ones just a little bit this way. And so he opens his mouth and closes. So now we've just covered the basics of creating a skeleton rig, applying it to an object, then deforming that object, and then animating the rig. One really helpful tool that you should learn how to use is the animation mixer. This will help you create animation cycles and build up an animation library so you can export different cycles for a character. The animation mixer uses a non-linear animation system, which means you can animate independently of time. What we can do is animate and create clips, and then drag and drop those clips and edit them in a similar way as a non-linear editing system. So the first thing we'll do is create a model for the hierarchy structure of the skeleton. So let's change our schematic view to the Explorer, and we'll select the skull and the root object, and we'll go to Model Toolset, select Model, New Model, and what this will do is essentially create a container where all our clips will be saved. So now, let's animate. I'm going to open up with 9 on the keyboard the schematic view, and then I'll leave it over here so I can easily select my bones. So first, I'm going to animate the head bone. What I want to do is animate a head turn. So I'll select the head bone object, then I'll go to Rotate, and I'll set a keyframe at the first frame, and then I'll advance about 15 frames, and I'll rotate it, and then I'll advance more and rotate again. I can turn on auto key also to make this easier. At frame 45, I'll copy my frame 1 keyframe. So now scrubbing through, we can see we have the simple head turn.
Now, let's middle click on the skull in the Explorer so that we can select its entire hierarchy.
And we'll switch to the animation tool set. And under actions, we're going to store. We'll do transformations,
Animated parameters F curves.
This will create a clip, and we'll call it head turn. It automatically detects the beginning and the end frames of the animation cycle. We're going to remove the original animation, and we'll leave the Add Source as Clip in the Mixer unchecked. We'll add it to the mixer manually later on. So now once we hit OK, our keyframes are now gone. So let's animate the second motion. This time we'll go up and down instead of left and right. So we'll set a keyframe, then advance about 15 frames, move it down, advance, and then move it up, and then we'll copy our keyframe from frame 1 to this frame here. Now scrubbing through, we can see our head nod. Now we'll go back to Store, animated parameters, and we'll call this one head, up, and down. And let's do one more. This time, we'll open and close the jaw. So add a keyframe at the beginning, and then we'll advance some frames. Now we'll rotate the jaw to be open. We'll advance some more frames, and then we'll close it again. Once again, we'll copy the value from the first frame to this frame here. So now we'll store this. And we'll call this jaw open. So with the object selected, if you click on refresh, you'll get two mixer tracks. We can then right click inside the mixer and click insert source, and we'll see our clips that we just created. So we can pick any one of these. I'll start with head turn, and now you can drag that clip backwards and forwards within our timeline. You can scrub through the timeline and see our animation. And what's great about nonlinear animation is we can move this clip anywhere we want. You can move it in the middle here, scrub through, etc. So now, if you look in the Explorer, underneath the skull, you'll see your mixer, sources, animation, and then you'll see all the clips. So we can actually drag and drop the head up and down animation, and the clips will blend together. You can see there's a noticeable jump where the clips are no longer overlapping. So what we can do here is mix these clips together using a standard transition tool. Under Mix, we can choose a standard transition tool and then click the clip that we want to have a transition. What this does is it smooths the ease in and ease out of the two overlapping clips. Now let's add one more, which will be the jaw open. First we'll go to the track menu and choose Add Animation Track, and then we'll drag and drop the jaw open clip. Pressing spacebar changes our selection mode so that we can drag the clip left or right in the timeline. We can also scale the clip to either speed it up or slow it down. You will also notice two sets of numbers on every clip. The bottom set of numbers indicate the start and stop motion points in relationship to the original keyframes, while the top numbers indicate the in points and out points of the clip in relationship to our timeline as a whole. So now I'm going to mute the top two tracks so that I can focus on the jaw open clip. By dragging on the edge of the clip on its middle axis and pulling outwards, I will scale the clip so that its motion is slower. Likewise, to make it faster, I simply drag inwards to shrink the duration of the clip. By dragging in the bottom axis and pulling outwards, I will create a clip cycle. A clip cycle allows us to loop our clip for a duration that we specify. To get rid of the cycle, simply drag again from the bottom inwards. Clicking on the top of the clip and dragging freezes the last frame of motion for a duration we specify. We can get rid of that the same way by dragging inwards from the top. So now, let's enable all our clips, the turn and the nod. And we'll scrub through. And we see that he's opening his mouth away from us. We actually want him to open his jaw when he's facing towards us, so we can move this clip over here. We can slow it down a little bit. And another thing we can do is add preset weights. By right-clicking on the clip and going to the preset weights options, we can add an ease in, which smooths out the animation curve, or we can undo this and try some of the other presets. Another option is the Gaussian 0-1, which is a smooth parabolic curve. Which is another way to smooth out the animation. So now, if we play back our animation all together, you see a smooth mix of the motion of our three clips combined into one animation. When you export animation, you will export these tracks as complete tracks. But you can also select all the tracks and create a compound animation. So select each track, under the clip menu, choose Create Compound, and you will see all our tracks become mixed into a single track. With this single track, we have all the same options as we had before, which includes scaling it, moving it on the timeline to change its start and stop point. We can even add an extra track, such as the head nod, and mix that with our compound track. So this really shows what's great about nonlinear animation. We can even extend the last frame of the compound source, or do cycles. You can shorten it and cycle it. It's pretty cool. So this is the basics of nonlinear animation. Now, let's see how we can create an animation in our custom props and then export that animation to the world of Half-Life 2.
The Valve source tools come with different character rig presets that you can use on your characters: male, female, shadow, biped guide. Let's open up the male, for example. I'm going to open up the Explorer, and if you open up the Valve biped, you will find a lot of nice groups that will help you animate and envelope your characters. Essentially, these are a group of bones that you can use for the enveloping process. And there are lots of nice helpers to basically guide you through the animation of your character. These guides allow you to rotate and translate different elements of the rig and provide a realistic response. Make sure you check out the Noesis disc on character design, which covers how you use biped guides to create your own custom rigs. Now, let's go to File, Open, Animation, and choose the skeleton rig. Press 8 to open the Explorer, and you can see that underneath Model, you have a skeleton low-res object. First, we're going to translate the object to reveal the character rig beneath. And now you can see the rig that we have set up for this character. We're going to envelope using this rig so that we can deform the character. So now, let's go back to 0. And then let's select the object, go to Envelope, Set Envelope, and select Yes. And now let's explore the valve biped. Here you can see a group of bones we want to assign the envelope to called Envelope Deformers. So middle click, and then right click to finalize our selection. So now when I move, I can deform the skeleton. Now what we need to do is select groups of points and assign them to the most appropriate bone. The reason for this is because when I move some parts of the rig, it will deform some parts of the body that I actually don't want affected. You can also select objects and click on the paint tool to paint each bone individually. You can see here we have the spine. Now let's go to display options, and under X-ray mode, let's change it to overlay so that we can have some visibility to the bones. So let's say we want to assign this hip bone to the spine. We can select the deformer that we want, and then press W to enter paint mode. Make sure you're in Add, and then just start painting. Now, when I move the arm, you can see the pelvis is no longer being affected. You can spend quite some time adjusting points, and you should. It's pretty simple. Just select the bone, then go into Paint, and start painting. Pick this bone, press W, and start painting. You can adjust the radius by dragging the slider or using the middle mouse button. So depending on your character, you can get different results just by painting different weights. Now, if you want to pose your character, you can select different parts of the rig and make adjustments. So now let's start animating characters and getting them into Half-Life 2. So let's go to File, Open, and under DB Level Design, select Skeleton, and let's open the Skeleton Pose Chain animation. Let's switch back to our toolbars, and let's play back the scene. We have a looping motion of an animated skeleton. Let's make another similar animation and export it. So let's open Skeleton Posed Chain Rig Scene. So before we begin animating, let's take a look at how this rig is built. First press 9 and open the schematic. Shift Z to zoom, and you can see the green bone, which is the master bone, and then we have two child bones, bone 1 and bone 2. Bone 2 is the neck and the head, and bone 1 is the skeleton, or the lower part of the object. So if I rotate the upper bone, we've got a swinging motion. and the other bones will follow. By rotating the lower part, just this part of the skeleton will rotate. And then we have the head and the neck. So let's animate it. First, let's select all the objects in the scene. Under Root, Shift Select for Polymesh and Sphere. Go to Model and create a new model. We're going to save animation clips here. The first animation clip we're going to create is a random swinging motion, and we want to make it cyclic. First, we want to save this pose as our base pose. So middle click on Model to select the hierarchy, then go to Animate, Store, and then select Transformations, Current Values. Then let's save this as our default pose. And if you open up the mixer, we have our default pose. So after we've created an animation and we end up with a character distorted like this, and we want it to go back to the default pose, we simply select the pose we want, and under Actions, Apply Action. This will reset our pose to the pose we have selected. So let's start creating some animation clips. First, we're going to animate the up and down part of the rig. So let's grab this and rotate, and then select key, and then let's press auto key. Let's make this sequence 80 frames. Remove the loop and go to frame 80 and set a key. Now let's go to frame 40, which will be in the middle of our timeline, and let's create the opposite swing. So now when we play back, you can see a swinging motion back and forth. Now let's select the second part of the bone. Press the space bar and select the bone. And then at frame 1, let's swing it a little bit more. And then we'll match that keyframe at frame 80. And then we'll go to frame 40 and have it swing a little bit more in the opposite direction. This adds a little bit of realism to our animation. Now let's save this animation. Click on the model, Store, and then Animated Parameter F Curves. And we'll call this Move 1. Hit OK, and you'll see that we removed the animation and have created a clip. So let's restore our skeleton to its default pose by hitting Apply Action. Now, suppose we want the character to be swinging, slightly swinging that is, and let's say we want the character to react if it gets shot. We'll want the head to swing all the way back and then return back to its original pose. So let's try that. What we'll need to do is a simple animation. First, let's create an idle animation of the head barely moving. So let's start by adding a little motion to the head. Go to frame number 1, and with your auto key selected, rotate the head just a little bit. Just a subtle amount of motion. Then we'll go to frame 80 and set a keyframe so that it matches frame 1. And then we'll go to the middle at frame 40 and we'll rotate the other way around. So this will just give us a subtle movement in a looping motion. Now let's play around with the chain bones. Move to frame 80, and just a little bit, have it swing. Frame 1 has the same key as frame 80, and then at frame 40, have it swing just a little bit in the other direction. You can see when we play this with loop on, we already have a very nice swinging motion. So let's do the same thing to the upper part of the chain. Rotate it a little bit at frame 1 and have frame 80 match. And then at frame 40, we'll do the opposite motion. We'll play it back to see how it looks, and it looks good. So we'll export this motion as move 2. Go to Model, Store, Animated Parameters, F Curves, and we'll name it move 2. Now we'll select our default and apply action and make sure he's not animated, which he isn't. And now let's work on the animation that will be associated with the skeleton being shot. What that means is we're going to have to create some backward movement. So first thing, let's select this bone, press C for rotate, go to the first frame and set a keyframe. Advance some frames, let's say 15, and then rotate it like it was shot backwards. Then I'll go to frame 40. And let's bring it forward some. And then we'll advance some frames and move it back, essentially creating a pendulum motion. And then let's get our last frame back the same as our first frame. Let's press 0 on the keyboard to look at our keyframes. You can see this sinusoidal curve represents the pendulum motion we want our skeleton to follow. We want that motion to get smaller and smaller as the skeleton loses momentum after being shot. So we'll make these adjustments here. This looks good. And now let's do something similar with this other bone here. Set the keyframe with K. Swing back a few frames later. And then move it forward. Swing it forward. And then back again. And then let's copy the keyframe from frame 1 to frame 80. Now we'll play our current animation just to see how it's looking. Now let's animate the skull in a more dramatic movement. When the skull is shot, we're going to want it to move backwards very quickly. So let's put a keyframe in the first frame, and then let's go into rotate and move to the 5th frame and dramatically move the head way back. And then we'll advance some frames, and the skull is going to start moving forward again. Let's actually go back to the first frame and make the skull rotation a little bit more dramatic. Then it goes down, and then as it swings forward, it's going to start going back up again. And then as it reaches the peak, it'll start going back down. And then eventually it's going to go back to its starting position. So we'll copy the first keyframe and place it at frame 80. Now let's check out the animation. It's going a little bit too fast for me. So let's shift and select all these keyframes, and then from the edge, drag the keys so it expands the animation, and then we'll play it. It's a little bit better, but this keyframe right here is a little bit too high. So we'll rotate this back down a little bit, just like this, and that's a lot better. Once you're happy with your animation, save it by going to Store, Animated Parameters, F Curves, and save this as Move 3. And if you haven't already, now's a very good time to save the scene. Save as Skeleton Posed Chain Rig Clips. If there's a scene there already with that name, you can just overwrite it. So now we're going to export our reference model, our physics model, and our idle animation. So go to Valve Source, Export SMD, select the model, and make sure you have checked off Remove Top Layer Bone on the character rig. Let's go to our username, Source SDK Content, Half-Life 2, Model Source, Noesis, Skeleton Animated. And save it as the skeleton pose chain reference. Now select the object and go to Geometry Approximation. Under Polygon Mesh, remove discontinuity, and now we can export the physics model. That will end with chain_phys.smd. And finally, we need to export the idle animation. That will be chain_idle. Now let's export the motion clips that we just created. Select the model and press Alt-0 to get the animation mixer. Right-click over the track, insert source, and click Move 1. Let's drag this clip to frame 1. Play it once to make sure that it plays. And now let's export it. Go to Valve Source. It'll be a skeletal animation. And it will be skeleton pose chain_move 1. Now that that's exported, let's get rid of that track, and let's insert Move 2. Make sure it starts at frame 1, play it back, and once you know it plays back fine, go to Valve Source, Export, Skeletal Animation, and we'll call this _move 2. Now the same process, we'll delete the clip, we'll bring in Move 3, make sure it looks good, And now let's export move 3. So valve source skeletal animation underscore move 3. So now it's time again to compile. Let's look for the SMDs that we just exported. Under Steam Apps, Username, Source SDK Content, HL2, Model Source, Noesis, Skeleton Animated, and you should already have the QC file we're going to use, along with the reference, physics, and idle files, and the 3 new motion files that we just exported. So now let's take a look at the QC file. We have the model name and the model we're going to create. It's a basic QC file. You can see we already have some of the animation cycles already in the QC file. Sequence idle, which is the default. Then we have a sequence move 1 and sequence move 2, which will be recognized inside a hammer. And then we have the animation clips, skeleton pose, chain, move 1, and move 2. So let's add one more, which will be move 3, since we actually exported 3 clips from our XSI sequence. Change everything to 3 here. And then the rest of the QC file will stay the same, because it references the same physics model. Alright, so now let's compile. So back in Hammer, in Noesisville, what we're going to do first is make some room and move all of this right here a little bit to the right. Just like this. And then we'll move this one a little bit more right here. And this one also. Oops, this one. Right here, just so we can make some room. Because what we want to do is place 2 more in there. Move this guy just a little bit more in between those 2 guys. That's fine. Now let's bring in a prop dynamic. Let's go to World Model, browse for a model, and go to Noesis, Skeleton, and do Chained Anim. You can see our sequences in here, the ones we just created. This one's perfect, so we'll hit Apply. Okay. And now let's move this one upwards so that it more or less matches the position of the other skeletons. Almost there. That's pretty much okay right here. So now let's give it a name. The global entity name, we'll call it Skeleton Dynamic 1. And we'll give it a default animation of move 1. Let's duplicate with Shift and create another one.
and we'll call this one skeleton hurt. And for its output, on health change, we'll target skeleton hurt, and we'll set an animation to move 3. If at some point you forget which animation is which, you can always go back to the model and look back at the different animations. Move 1, move 2, or move 3. So what this should do is when you change the health by shooting at it, you will play this animation. We can also add a sound effect to our models. To add a sound, it'll be a generic sound, and its name will be skeleton hurt. In the sound name, we'll browse for it. We'll go down to the Noesis folder. And we have a couple of different ones you'll see here. After you preview the sounds, pick the one that works best for you. I think Hurt 3 is a good choice. We'll have the start volume equal 10. And keep everything else at default levels. Now select our prop. And go to Output and add on health change pick our skeleton for the target, which is skeleton hurt. And then let's rename our sound so that we can differentiate it between the prop name and the sound. So we'll call it skeleton hurt sound. And then go back to the output of our prop and add a new one, which is on health change. Target the skeleton hurt sound and go down to play sound. And then hit apply. And now, when we shoot at the skeleton, this sound will be played. We can close this. And one last thing before we compile, depending on the model you exported, some models can have some issues with collisions. So if you go to collisions, and if you're having problems with the V physics, you can change it to a bounding box. So in this case, we'll use a bounding box, and we'll select this model also. And now we can compile. So here you can see in our compiled world our animated props. We can shoot it and we'll see it takes damage. But this one, if we get closer and shoot it, it goes into our Move 3 animation. And then goes back to the default animation. These ones over here, they can actually break. Just need to inflict enough damage. There they go. So now let's try something different.
Let's make the animated props break. To do that, we need to leave the compiled level and then exit Hammer. So the only thing we have to do to make the objects breakable is something that we've already seen before, and that is get the lines of code that makes the object break. So in Steam Apps, Noesis 3D, Source SDK Content, HL2 Model Source Noesis, you'll see we have skeleton gibs. In the skeleton gib QC file, we just need to copy the collision text. Now, in our skeleton chain dynamic QC file, we simply paste that text underneath collision model. Save the changes, and then recompile. So now we can jump back to Noesisville and Hammer, and the skeleton should now be breakable. Let's also add one more sound. Call it ambient generic, and we will trigger these sounds when the objects break. Get the properties with Alt, Enter, and his name will be skeleton dies. And the sound name will be, we'll browse for it, go to the Noesis folder, it'll be die 1. Set the start volume to be 10. And now let's create a trigger for the sound. Hit enter, outputs, and add a new output. It'll be on break, and we'll call this one skeleton dies. And then play sound. In Hammer, you can actually copy outputs and paste them to other objects. And then that way we can have all our skeletons playing the same sound when they break. Paste, paste, and paste. Now let's select the breakable objects, and let's set their health to a number other than 0 so that we can actually break them. Let's set them all to a health value of 5. Selecting all of them. Add health value to 5. Another thing I want to do for these skeletons is I want to change the physics impact damage scale. This way it can receive more damage. So let's set this to 1. Okay, so now we're ready to recompile and test our world. Now, from the Viz groups on the right-hand side, under the User tab, let's enable the background trees and the extra set of sounds. Let's go ahead and compile the map. This time I'm going to use the normal rad. So now we're in our map, and we'll start by pushing these guys around. You can see these guys animate based on the trigger that was set up for them. And now let's just have some fun and break these guys. There he goes. And now this guy. And let's just get rid of all of them. So as you can see, gibs are a lot of fun. Not only do they add a great sense of realism to your maps, but they add a lot of enjoyability too. In our next exercise, we'll work with an animated prop and getting it into a different map.
In this section, we're going to be doing some character animation. So let's go to File, Open, and from DB Level Design, pick the dragon, and we'll go to the Dragon Mixer Clips. First, we're going to review this scene. We have a dragon with a skeleton, and you can select any part of the skeleton and press Alt-0 to get the animation mixer. I'm going to hide the implicit geometry and the chains. So this dragon already has some animation clips that we're going to put in the timeline. Right-click to insert source and select Wake Up. We can drag our playhead through the timeline to preview this clip. You can see the dragon awaking from a slumber. I'm going to extend the timeline to 300 frames. And then we're going to add another clip. So this time we'll pick fire, bring that to 0, and scrub through. You can see the dragon breathing fire, albeit invisible fire. Now in our case, this clip is a little bit too long, so one thing you can do is trim it by placing the playhead where you want the clip to be cut, and then from clip, choosing trim after. And now it's just the animation that we want. And let's add another clip, and this will be the flyaway. You can scrub through that. We see the dragon launching off into the sky. So let's mix these three clips together. He wakes up, breathes fire, and then flies away. We can add transitions between clips by going under the Mix menu, selecting Standard Transition, and then clicking on each clip. A purple line will appear to show the transition.
Right-click to exit, and now play the animation to see how it looks. It should blend together quite nicely. So what we've just looked at is that after you've created your clips, you can then use the animation mixer to create entire sequences, which you can then export. Now we're going to create our own custom animation. Let's open up the scene that's entitled Head Nod. Let's say, for example, we're in the game and we meet the dragon face to face and we shoot at him with the pistol. The bullet won't kill him, but it will make him angry and turn his head. This animation sequence is a good example of what that might look like. The dragon's angry, he shakes his head, he's reacting to the bullet, but he's not actually going to die. So let's go ahead and create something similar to this. Let's go to File, Open. Let's go to the dragon scene and open Dragon Rig Reference. Here you can see the skeletal structure that we can actually animate. We can select the head, press Z for rotate, and then move the head around. We can make the wings flap. If you find it difficult to select certain bones without selecting the geometry, you can press 8 to open the Explorer, press F to find the dragon mesh, and then once you find the dragon mesh, click on the plus icon to expand it, and then select visibility, and then turn off selectability. Now you are only able to select the bones, which is exactly what we want. We can animate the feet by transforming the boxes to where we want the dragon to step. So now let's start animating this scene. If you're wondering how to get the bones to show up over the geometry, that can be found underneath the display options. You can see that we have X-ray mode on. If we turn it off, it makes it much more difficult to model. If you wanted, you can go to wireframe mode, but in my experience, it's easier to have the visual feedback of viewing the solid geometry. You also have the choice between overlay or screen, which you can use, it's up to you, but I'm going to go with overlay. So we're going to do a 60 frame animation. And usually the way we animate is to animate the body movements first, and then later concentrate on the subtle details. In this case, we're going to start with the center of the skeleton. So frame number 1, we'll keyframe it in its default position. This way it will blend from our other animations well. We'll click Translation and set a key, and then Rotation and set a key. And then on frame 30, actually let's make it faster and go to frame 15.
we'll translate and move it back a little bit. And then let's set a key. We can also turn on auto keyframe. So let's actually make it move a little bit farther back. And a little bit lower. Now let's click on this bone, which is at the center of the spine. We'll add a keyframe at frame 1. And then around frame 20, we'll angle it down a little bit. Now let's work on the head nod, and we'll start with the neck. Select the neck, add a keyframe in rotation, you're going to move it this way, up a little bit and to the right, and then more right, and then we'll have it return to its default position. Now let's work on the head. When it receives a bullet impact, we'll set a keyframe, and then at frame number 5, we'll make it something like this, just down a little bit. And then we'll advance some frames and have him move up so that he's looking pretty angry. Kind of swings his head to the other side. And then we'll have it swing his head really fast to the other side. And then we'll have it restore to its default position at the end. And let's see what this looks like. I'm not really a fan of this keyframe right here, so we can just delete that and then see how it looks. This is a bit of an awkward pose, so I'm going to adjust that one a little bit. Starting to get there. A slight adjustment right here. And I think that's much better. Now let's animate the wings. So we'll do the same thing that we usually do, which is set a keyframe at the first frame. So we can set the keyframe for all the bones, at least the principal bones, and then set a key. And then when it's hurt, we'll want the wings to just twist a little bit. You just need to imagine your pose and then make that pose come to life. So we'll check this out. And then we'll need the wings to come back. So what we need to do is copy the keyframe from frame 1 for every bone that we moved to the last frame for both translation and rotation. So I'm going to go ahead and do that now. So the spine and the head return to the pose. And we also want to get the wings to return to the default pose. So we'll copy the keyframes from frame 1 for all the bones that we moved into the last frame. Now we'll play it just to make sure it returns to the default pose. Looks good. Now let's work on the head a little bit more. So I'll add a keyframe. Just smooth out the motion here a little bit. It's looking better. The end is still a little bit fast, which could either be the head keyframe here or the neck. The neck looks fine, so we'll play it through. It's much better. So now let's animate the feet a little bit. We'll go on the translation tool, add a keyframe, and since we know we want it to come back in the end, we can go ahead and add that keyframe now. So when the dragon gets hit, I want this foot here to pull back and rotate a little bit. And I realize now that I forgot to put a keyframe for rotation at the beginning in its default pose. So I'll undo and I'll put a keyframe for rotation. And I'll make sure to add that rotation keyframe at the end also. And then we'll go back and then pull the foot back and rotate it. Okay. Let's move it back just a little bit more. Right there. We'll watch it, and then let's actually move its ending position to be a little bit earlier. That's a lot better. So we're almost done. But before we leave, I think it would be a nice little touch to animate the tail so that it coils when the dragon gets hit. We'll select the bones in the tail, get all of them, and then we'll add our first keyframe at frame 1 for rotation, and then around 40 something, we'll add that same keyframe. And then we'll jump to frame number 10, and we'll rotate the tail. And what you'll see here is that when we rotate in either view, local, or global mode, when you rotate, all the bones rotate in the same basic position. We don't want it to do that. We actually want it to rotate so that each bone itself is slightly moving so that we have a curling effect. To do this, we'll switch it to add mode, and then when we rotate, it'll actually add values to each of the bones in the tail, just like this. So now let's play it back. And actually, let's twist it a little bit like this. We can move the keyframe a little bit to the right So it happens a little bit slower, and I think that's much better. So let's take a look at our animation without the chains and the implicit objects. Play it through. I think this foot's too static. So let's move that foot. We'll enable the chains again and the implicit geometry. And then we'll add our rotate and translate keys at both at frame 1 and then at the end. So now let's move it a little bit here. Play it back. Give it a little bit of rotation. Let's move the whole body a little bit more in this keyframe. It's looking pretty good. The last thing we can do is animate the jaw. Let's start in the default position and put a keyframe, and then the same position at the end. So when it gets shot, it will close its mouth. And then we want it to open and growl. So put a keyframe here, and then advanced, and this is when he'll open, because he's pretty angry. Let's switch to view, and now move it this way. Close it a little bit here. Open again. And then returns to default, which we can have happen a little bit later. And then we'll have it close again before it returns to the default. Play that back. Can make some minor adjustments to the timing by moving keyframes. So let's take a look at it without the chains. It's looking pretty nice. Definitely good enough. You can definitely spend a lot more time if you want to make the animation look better. But right now we're going to export our animation. So first, let's get the Explorer by pressing 8 on the keyboard. Let's find the dragon. Click on Visibility. And enable Selectability. This will once again enable us to select our dragon. So now go to Valve Source, Export SMD, and from Steam Maps username, Source SDK Content, HL2, Model Source, Noesis, Dragon, and we'll override the dragon_nod.smd. And this will be our skeletal animation.
From your username Steam Apps folder, Source SDK Content HL2, Model Source, Noesis, Dragon, you'll find the QC file. Let's take a look. The basics are still the same. You have the model name, the reference, the different sequences that we've exported from XSI, idle, nod, fly away, and fire. This here is the sequence that we exported from XSI. So let's close that and drag the QC file to the studiomodel.exe. We'll compile it. And now let's look at the compiled model in the viewer. We'll load a model, go to the Noesis folder, Dragon, and pick the Dragon model. In sequence we have idle, which is just as flapping its wings. Then we have fire, where you can see he's breathing fire. And then we have fly away, where he turns and flies away. We also have the sequence that we just created, which is nod. If you pull up XSI, you'll see the exact same sequence. So let's put together a scene where we can use all these animations together. So this is kind of like a storyboard of the scene that we're about to create. We're going to start off with this background here, and then we'll create a layer for the dragon. We're going to be starting on this part of the bridge, and there's going to be a dragon in here. From the first person perspective, this is what we'll be seeing. The dragon will be sitting in the center, and we'll have to cross the bridge. The dragon will be sitting between these fangs here. We'll set it up so that the dragon throws fire at us when we try to cross the bridge, and somehow we need to figure out how to scare the dragon so he flies away. So let's get into Hammer and get started. Open up the scene entitled Dragon's Lair. Feel free to navigate the scene a little bit. So what we have going on here are some lights that are set up, some props that are already placed. You have your player start here. The bridge, and of course the dragon's lair. Let's get started by placing our dragon. Let's get a prop, a dynamic override, then we'll go to World Model, Browse, Noesis folder, Dragon. Then when that loads, we'll click on the dragon. And now we can see our sequences. Got idle, we have nod that we created. Fly away.
and fire. So we'll select the dragon and then apply it. And let's add a name. Just call it dragon. Let's move it a bit back. Right there. Maybe just a bit more in line with the bridge. Perfect. So right now, let's go to our default animation and call it idle. Now, if you were to compile right now, you would actually see the dragon animated, its wings flapping. So now we want to trigger an animation. So what we'll do is when the dragon receives damage, we'll have him do the head nod animation. So hit Alt-Enter, go to Outputs, and let's add an output. On Health Change, the dragon, and we'll set the animation to head nod. It's important for that animation name to be correct, so let's double check here. And we'll check out the model sequence, and we see it's actually named nod. So let's go back and call it nod. So now, with this output in place, if we were to shoot at the dragon and he receives damage, his head will nod. Before we go any further, let's test this out. So we'll compile the map. And let's see what happens when I shoot at him. There you go, you can see when I shoot him, we've triggered the animation. We should definitely add some sort of sound to this. It should roar when it gets damaged. Right now we can't kill the dragon. This is actually the whole idea. You can't really kill a dragon, you have to scare it away somehow. Okay, enough of that. Let's get back into Hammer. So now let's create an ambient sound, so that when the dragon is hurt, we can hear it roar. Under Objects, let's look for Ambient Generic, and then we'll call this Dragon Hurt. And the sound name, let's look at our options. Go down to the Noesis folder. And we should have Dragon Nod. We'll set up the start volume at 10. Now let's set up a trigger so that when we start to cross the bridge, the dragon will breathe fire. So let's first create a brush. Where we want the brush would be more or less around here. And we'll make it tall, around that height. a little bit taller. And now let's give it a texture of trigger. With the object selected, press Ctrl-T so that we can tie it to an entity type. Let's create a trigger multiple. And we'll call it trigger. And we'll make sure start disabled is on no. And that's it. So the first output will be when we touch the trigger, which is called on start touch. The target entity will be the dragon, and we'll have set the animation to be fire. We have to make sure that is the name of the animation. Go to model, and yes, it is fire. Great. So that way when we cross the bridge, and we can actually probably move this in just a little bit more, like this. When we cross the bridge, the dragon will breathe fire. Let's move the dragon a little bit back like this. Okay, that's good. Then we can create a second sound, which will be heard when he breathes the fire. So let's create an ambient generic. Give it a name of roar. And the sound name be under Noesis folder. We'll choose the dragon fire sound. Start volume will be 10. And now we'll trigger that sound. From the output, add on start touch, and we'll set the target entity to be roar, but actually we probably should rename that to be roar sound. So we'll go back to that sound. And then for sound name, we'll call it roar _ sound and apply. And then our trigger will target the roar sound. And then we'll play the sound and apply. So right now what I have set up is first when I shoot the dragon, he will animate his head up and down and make his hurt roar. And then second, when I cross the bridge trigger, the dragon will breathe fire and make a fire sound. So let's compile the map and confirm that. So now let's shoot at him. And the roar and the animation is still in place. And if we go through the trigger, he roars and breathes fire. So far, so good. So let's continue adding more actions. the next thing we should do is actually have him breathe fire that we can see. So let's get closer in, and then let's add an environment fire. We'll put this object just a little outside of his mouth, like this. And we'll call this fire. Apply. Start disabled should be no. Duration, change it to 2 seconds. Size, we'll make 80 to make the flames bigger. We'll set attack to 0.05. Apply. Type will be natural. We'll set the ignition point to 1. And the damage scale will make 50. And apply. Close that. So let's go to the trigger and add an output that will be on start touch fire. So on start touch, we'll target fire, and we'll start the fire with a half a second delay. Now what I'm going to do is duplicate this fire a couple of times just to make sure it's working fine. So let's try this out. Compile. Shooting the dragon still triggers the roar, and crossing the bridge triggers the fire. It works well, except I think it's a little bit too fast. We should trigger the delay to be a little bit slower and a little bit later. So let's go back and try that out. So we need to adjust the trigger. So let's select the trigger, and under Outputs and Fire, we'll change the delay to 1 second and see if that looks better. And now let's select all the fire. We can go to the Entity Report and select all the fire objects. And let's deselect these 2 flames that are in the back. And now, let's adjust these flames so they're closer to where the mouth will be breathing the fire. We can actually try it out by selecting the dragon, going to Model, and the fire animation, see where it ends up. So that's pretty good. I'm going to adjust this trigger just a little bit. And now let's try it out. We probably can add to that delay just a little bit more. We can also remove that smoke. It's definitely looking pretty good. So let's go back. We'll set the delay to 1.8. And then let's select all the fires. And we'll create a fire group. So we'll go to the entity report. Select all the fires. And then make sure the back two are deselected. And confirm you have all the front fires. And then the object properties and the inputs, you'll see all our fire. And we'll go to Viz Group, do New Group, and we'll name it Fire. And then we'll go to Fire and make it smokeless. So let's go ahead and see what this looks like. So that's too much of a delay. You can see now there's no smoke over the fire. So let's go back and make some adjustments. Let's go back to the fire delay and let's set that to 1.2. So now let's add a little bit more action to this scene. First, let's duplicate some more fires. Select the entire front group of fires. Press Ctrl E to center on the selection. And we're just going to move it with the Shift key. And just keep on duplicating. Duplicate up, duplicate down. Now let's randomly select some of these fires and move them, just to expand it a little bit. Ideally, we want the flame to have more of a random, natural feel. Something like this. This should give us some good randomness. So now we need to figure out how to scare the dragon. Under our Viz groups, let's activate the columns. And you should see 4 columns, like the columns we created before with Breakable gibs. These right now are set up as prop physics override. Now in the Viz groups, go ahead and enable the ledges. These ledges will hold up the columns. And now let's enable the roof. The roof is the key here. The roof is simply a func breakable entity, which we can check out here in the object properties. Func breakable. And so what we want to have happen is make a math counter, and when the roof breaks, the debris will fall down and scare away the dragon. In order to break the roof, we have to break the 4 columns, hence the math counter. The way the math counter works is it adds, depending on how many columns we break, so that when the math counter reaches a specific number, in our case 4, we can then actually break the roof. So let's add the math counter. So we type in here math counter. You'll see our object pop up. We'll get the properties. We'll call our name counter. The initial value will be 0. And our minimum legal value will be 0. And our maximum legal value will be 4. And now we need to make sure that each of our column names is unique. This one's column 4, column 2, column 3, column 1. So the way the math counter works is fairly simple. We'll go to the object properties outputs and set it up so that when the maximum number of hits is reached, the roof will break. So we'll set up the output to be on hit max, the target entity to the roof, and the action will be break. And we'll set the delay to 0.6 and apply. And now we need to add to the counter. So let's go up to the columns. Let's click on the column and add an output. On break, add to the counter a unit of 1. And now we can copy that output to the other columns. So right now, when the 4 columns break, the math counter will reach its maximum value, which we set up for 4, and then the roof will eventually break after its delay. Here we can confirm our maximum value is 4. So let's test this now. So the dragon still roars when it's damaged. The fire looks good, but it looks like it hurts the dragon. So we need to set up a filter so if the dragon isn't damaged by fire. Now let's test the columns. One. We need to set a damage filter for these columns so that they don't break with the pistol. 3. 4. So right now our math counter is not working. You can see the roof didn't break. So let's go back and see what went wrong, and also set a damage filter for the dragon. First, let's set the damage filter for the dragon. So we'll go to Filter, Damage Type, and let's call this object Dragon Burn. The filter mode will be Disallow Members, Damage Type Burn. And now let's set this filter for the dragon. So we'll click on the dragon and go to Damage Filter and set that to Dragon Burn. Now the dragon won't be hurt by the flames. Now let's figure out why our counter is not working. Outputs. So that looks alright. Roof looks alright. Let's make sure our columns are adding correctly. We have it targeting a counter, so let's make sure our counter is also called counter. It is. But let's change this to column counter just to make sure. Then we'll go back to our columns. And here we see on break, column counter, add, and here's our mistake. We have 1 for a delay, but we actually want the delay to be 0. So select the 4 columns, go to outputs and change the delay to 0, and our parameter override to 1. And let's change our prop data to stone large for the roof. The material will be rocks. And on top of the roof, let's go up so that we can enable debris. From the viz groups, enable the debris, which you can see is just a bunch of physics stones on top of the roof. And let's also enable the cave background. And now let's try it out. Our fire looks better. Maybe a little bit too late. So let's take the RPG and break the columns. 3 and 4. Excellent. We now see that it works. So let's go back. So now, let's trigger an action so that when the debris from the roof falls, it'll scare the dragon and it will fly away. So what we'll do is we'll use the same roof as a trigger. We'll select the roof and go to Outputs, Add, and on break, target the dragon, set the animation to fly away, and now we'll make sure that's the correct spelling of our animation. So go to the model. You can see it's fly away without the underscore. So let's go back to the properties of the roof and change that to fly away. Now the delay should be essentially the amount of time that it will take for the stones to fall from the roof and reach the dragon. So let's say 2 seconds. Also, another thing is when we scare the dragon, we don't want the trigger to ignite the fire as we cross the bridge. So let's disable the trigger once the roof breaks. Let's add an output to the trigger of on break. We'll target the trigger and we'll change it to disable and apply. Now when we go back and forth over the bridge when the dragon's flown away, there won't be any fire. And let's also add another sound clip. We'll add an ambient generic. And this sound will be the dragon flapping its wings and soaring out. So we'll name it Fly Away Sound. And we'll browse our sounds under Noesis. And we have Dragon Fly. There we go. And lastly, we need to set a trigger for that sound. So go to the roof, and in its properties, we'll add an output that on break, the dragon fly away sound, there it is, we'll play the sound. And we'll set a delay to 2 seconds. Another thing we should do that I mentioned before is set up a damage filter for the columns. So let's create a filter. Filter damage type. And we'll call this column explode. We'll set it up so that entities have to match this criteria, and the type will be blast. Now let's select the 4 columns, and we'll set each of their filter to column explode. Let's try it out. So right now, the fire trigger is set. The dragon's not being damaged. The pistol won't destroy the columns. So let's switch weapons and break them. The roof breaks. The stones fall. And the dragon flies away. And now we can see that we need to set an action so that the dragon is removed from the game once it flies away. So let's go back and work on that. So one way to solve this is to add an output to the roof that says that on break, target the dragon, and we'll kill it. And we'll set up the delay to be 7 seconds. And now let's add some smoke for them when the rocks fall. So let's draw a brush, more or less around the area where the dragon is. Something like that. Hit enter. Control T to tie this object to an entity. And under object properties, we'll call the class Funk Smoke Volume. We'll set the density to 0. Now let's add an output on the roof. But first we need to go back to the smoke brush and actually give it a name.
So we'll just call that one smoke. And then we'll go back to our output on the roof. And go on break. Target the smoke. And we'll set the input to set density. Then override a 1 and a delay of 2 seconds. And we'll copy this output and paste it here. And we'll put it back to 0 after a delay of 6 seconds. Or let's say 7. Now let's try it out. Let's get on a blast object. There's one column. There. And the last column. There's the roof. There you go, you see the smoke. And it should now fade away. And the dragon does not return. Now let's return and unhide the rest of the map. So let's add a little bit more ambience to this level also. Dust motes is a good way to do that. So we'll create one more brush around the area of the player. This is good. Then Control T to tie it to an entity. And we'll do it func dust motes. And we'll just call this dust. And now let's unhide the rest of the elements in the map. You should remember some of these guys from previous lessons. So before we compile, we just need to add one last thing. Let's add some shaking when the columns break. So let's do an environment, shake, and place it next to our character. And we'll call it shake. So what we want to have happen is when we break the columns, we want the shake action to be triggered. So let's add some values. We can do an amplitude of 16, an effect radius 2000. Duration should be around 2 seconds. Apply. And let's trigger this with the columns. So we'll click on a column, go to output, and add an on break, target, shake, start shake. We don't need any delay. And we'll copy that and paste it to all 4 columns. So now we're ready to go. Let's check out our final map. So there are our friends from the previous lessons. All these guys can be blown up into gibs. Dragon gets angry when we shoot at it. Breathes fire when we cross the bridge. There's more of our friends hanging down there, which we can also blow up into gibs. Now let's try to scare the dragon away. One column. Notice the level shake. 3 and 4. 4. Smoke. Dragon goes flying off and doesn't return. Whoops. Well, I hope you liked this lesson. And now you can actually see the potential of adding custom props and gibs to your map. Let's try it one more time. First we'll kill some of our friends here. Let's rocket launch one of these guys down here. It's probably easier with the crossbow here. There we go. And last but not least, let's blow off this roof. You can see the levels shake when we blow off the columns. And 4. There goes the roof. Dragon scared, flies away. And now we're free to cross. So once again, I hope you enjoyed putting this level together with us, and I hope you enjoy using custom props on your next level. See you next time.